Good evening, sir. Afternoon.
And
So
how are you doing today?
I am, so for want of a better word, I'm awake. Not alert, but awake.
Guess what?
Yes, sir.
Um, you're alive.
Sir,
I'm saying you are alive.
I'm alive, I'm alert, but, well, not alert, I'm saying I'm awake. I don't know
Mhm.
what to say. Sir, I didn't really get a weekend. We had a exam mid-semester, and I said, what? Apart from studying, like gone all kind of issues. But I'm giving thanks, sir. As you said, I'm giving thanks. I have life.
Oh, tell me about it. So many others would want to switch places with us
True,
because they're lying in their graves.
true.
We are standing on ours. So, you know, it's just my positive way of
True.
looking at the glass being half full rather than being half empty. But we will get this. We will get this. This is not going to beat us. We're gonna conquer. We're gonna conquer this challenge. But importantly, though, how are things going? The studies feel okay. Do you think that you're on top of
Right.
things?
Sir, it's not that I'm discouraged. I don't think I'm discouraged. I think I have it covered in my book from the working notes from what you showed us and the things that you sent us. I was practicing.
Hmm.
So I want to ensure that when I actually do the test, I get a very good grade. The
Hmm.
last one I did, which was, I mean, we did it before, so it was almost easy, so to speak.
Hmm.
Oh Lord. Sir, I'll tell you how it go. Sir, so I'm saying I wasn't discouraged as such, but it is something that we've done before. That last one that I did on the system on Educasoft, and I ended up with a half, not half, well, two-thirds of the mark is because I was looking at the graph. I'm nearsighted already now, and trying to figure out what part of it they're referring to. Because the one I did in practice was showing me something else, and it was almost confusing. I work it out and I got those sections right, but looking at the graph, I don't know if it's my confusion or I'm half blind. I don't know, but that part, I was looking for the 100, and I need to stop. But I'm going to, sir. Between tonight and tomorrow, because I get in tomorrow as a work from home day, I'm gonna try to do some more at Educasoft as much as I can. Over the weekend, I just never got the chance to do it, sir. If I tell us a light, go away, and it's not even JPS fault. It's not that the bill no pay. It's that we have some neighbors that like to borrow when I belong to them. Jesus.
Oh,
And
tell
it's
me
always
about it.
around exam time too.
Tell me about it. Tell me about it. I had I
Let
had
me head
some
home. Let me just thinking about how the business day.
I had
I
some
have things
one
I
year
need to do.
um, one year I came home from work.
Mm-hmm.
I would have had about maybe 5 6 hours before my next class,
Mm-hmm.
etc. not sitting down at work. I'm gonna come home, eat something, lay down, watch two tech TV, and
Mm,
then cool off. And I was driving on the avenue. I saw the guys
mm,
from a cable company on the light post. So, went, grabbed some food, turn on the television, and
mhm.
in about a minute after turning the television, bam, it gone. So I said, I don't
Like,
understand. No, so I went, no, it was
all right.
the cable that went.
So you
So I
know the
went
feeling, sir?
outside, went
Oh,
outside,
go
and I
ahead.
said to them, guys, what key? You cut off my cable? And the man them said,
Mm.
but you don't pay the cable bill. I said, don't get rude. I said, no, don't do this to
What?
this. I said, don't do it. Don't do it to this teacher. This teacher pays his bills. Don't do it.
Mm.
And when I stood up at my gate and the guy called the office and he says, who is the account holder? And I told him, I am. And I gave him my name. And he apologized to me profusely to say that
Oh,
I am the real owner, but the amount of extensions that came off my cable,
oh
he was
God.
surprised to know. So they had to disconnect it. I was like, oh my
Oh God.
goodness. So I had some
Mm-hmm.
very unscrupulous neighbors,
Thank
um,
you.
so I know exactly what was happening. And I mean, I don't know how to do it. I don't know how to do it, but
By night, sir, by night. You in your
yeah,
house, you see the light dip a little, you know something going on. And it was doing that up to last week, a week before last. And I said to mom, mom, you need to call JPS and tell him something is wrong. She's like, if you do that, somehow it leaks back to you and say that is you do it and people are gonna have you. I don't care. They're not paying no bill for me.
you need to do. Just decide that, make up in the mind one day and say, okay, fine. Um, wanna come disconnect my night for me? Disconnect
Yeah.
it.
Yeah.
And me telling you, I'm gonna be inconvenienced. Disconnect my night for 2 days.
Mm-hmm.
All right, and me telling them to come put it back on, and
Yeah.
then no, everybody's going to be scampering again. You say, oh, so when my light gone, your light gone too.
Exactly. No, but we know
Yeah,
who we know.
yeah.
To be honest, Sir Shand, we know is who we know where because you can walk along the road and see where the line throw up. We had them disconnected some time ago,
And
It happened
but
in January that I lost all my light, everything. And we got everything. We cleared off the line, all the cobweb, everything was taken down. JPS come, we call them and tell them come take them down. And we were okay up to that point. And just within the last 3 weeks, the lights start flicker again. So we know low voltage. I put my phone to charge all 3 hours, may I wait feet and I realize it's a low voltage. That is what they're doing. They're taking what is ours. So, sir,
and you're right. You
right.
talk about it and you go you walk a road and man see and looking at knee and say,
Thank you.
yeah, life is
It's
it's
rough.
it's, it's unfair.
But sir,
It's unfair.
I panicked when it was time for the exam and I realized I still didn't get back light. I panicked. So I start raise hell. I didn't care who I'm vex and they call the electrician to come and take down the cobweb and we finally got back light. The meter spinning and we not getting a light, that not right. So sir, I give thanks. I have life.
And electricity is so darn expensive.
Thank you. The bill, oh God.
But
Sir, I'm just giving thanks. That's
you
where
know
what I'm
what?
doing. I'm giving thanks.
Um, as we prepare to begin, as per usual, my words of encouragement is that if you fail to prepare, guys, prepare to fail. The the work is not going to get any easier, um, but it is not something that you cannot manage. As I said before, um, so many students have done it in the past, um, and you too can do it. And guess what? The students that have done it in the past are no smarter than you are, because I don't consider you challenged the class, as a matter of fact, challenged in any way, shape, or form. So I'm expecting you to do. So if any of you feel a little apprehensive, a little fearful, don't. You can do it. The only
I
thing I would say to
appreciate
you,
that, sir.
yeah, man. The only thing I'm going to say to you, you have to be diligent. Now, one of the things that used to happen to me when I was going to school, they used to sell songbooks. When you catch half a tree, you can go down a Bendon Plaza and buy one songbook for $50. $50 them time, yeah. $50, yeah, $50 or $20. Oh Jesus. Anyhow, some little bit of money. And all of the hit song them the in the book. Now, when you want to learn the song, don't go study the words of the song. You play the song over and over and you know the words inside out. So the days of Barry G, just dated myself on RGR, so you know how long ago that was.
Yes,
You,
sir.
you used to come home and turn on the radio, and when Barry G lit them something, you know, sit down in front of the radio and you start sing, and you do this every day. Within a week, you know the song. What's the point? If you try some stuff
Practice.
and practice,
Mm-hmm.
there is no way it will not get to long term memory. It has to get to long term memory because this is how we were created. If we do something once or twice, thrice, trust me, by the fourth time, it becomes easy one, two, three. So if you don't do the work beforehand, it is going to cause some problems. But if you work continuously, I guarantee you it must bear fruit. When I say it must bear fruit, you can't water a plant once for a week unless it's a special plant like an orchid and expect it to flourish. You have to do it on a daily basis, just like how you and I eat on a daily basis. So we have to put in a little work. So I guarantee you, if you do what is required of you, trust me, very little is going to be required of you towards the end because you would have put in the work. So one may say to me, sir, be mindful that is not just math alone we're doing. And I'm very cognizant of that. You have to pace yourselves. And again, I'm going to ask you, create a study timetable. Create a study timetable, and you can say, I finish work at, we call it, sorry, I finish class at 9 o'clock most days, 10 o'clock on a Tuesday. Guess what? My study timetable is going to involve me getting up at 4 o'clock or 3:30, and 3:30 to 5:30, putting them 2 hours. Students, my students, some of you, I'm seeing one of you here who is at the bachelor's now, and the rest of you I know are finishing off the associates. It came to a point. um, there was a course that I did that had a high failure rate, and those of you who have taught before me have heard this, a high failure rate. And the students a year above us came to us one day and said, don't play with this course. If 10 people do it, two can pass. I mean, saying, you need to be another two, that's me not do it over. Well, with my luck, I was one of those who failed the course, along with all of my friends. The only people them who pass the course is the bright Trinidadians, them and the and the Bayesian, them and them people. They was like, oh my crap. And I failed the course. But guess what? The pass mark at the university was 40%. Was
40, sir?
40%.
40?
Like four and a zero, yeah. But
Jesus.
don't worry about it. It was an each of a 40 to get. Trust me. Trust me.
Oh, God.
Yeah. And the thing about it, what made it difficult is that if you did for that particular course, I think there were four components to the course. There was a lab component, there was a fieldwork component, there was an exam component. There were three components to that piece. Yeah, there are three components to that piece for the thing. And 40% was a pass mark. Now, you know, when them average your teacher percentage, you know, so they get over 50%. I got over 50%.
Wow.
One would believe that I would have passed the course, but
Yeah.
I failed the course because
How, sir?
my field work was good, my lab work was good, but I messed the exam up terribly. Now,
Oh,
even though when they averaged all of the three pieces, I would
mm.
have gotten a grade greater than the pass mark, I still failed because the university had still does. The policy is you have to pass every
Oh.
component that you're examined on, as
Mhm.
opposed to Excelsior, where it is that any combination of 50 gives you a pass. We had to
Mm.
pass all the
All the
components. Now,
course.
fortunately, my friends and I were in pretty much a similar position. So fortunately, we only had to do over the course, the exam, not the lab work and the field work. And I remember the following semester, no, the following school year, because it's not like, we can have a fast track class where we can, we don't pass a course and this next semester we can do a course. Not like that at the university. Actually, no. You guys, you guys are living life at said. I'm telling you. So when the
Right.
following school year came and we all went back, the whole host of us that failed the course went back, and I sat down in the class and I was like, what the heck am I doing in this class? It is one of the most boring class. Why did I not pass it? And I sat down in the class and I grumbled to myself and I found myself not learning anything more than what I learned the first time. And I remember, real talk. I remember one night I came home, I had my study timetable. So this is the point I'm making. I had my study timetable and I went to bed. And for the life of me, I was tormented. And I literally heard a voice. If you want to fail the course again, sleep. If you want to pass the course, get up. And I'm going to tell you what the other thing that university did. They allow you to fail the course once. You see, if you fail a course, if you fail more than, they allow you to fail any course one time. If you fail a course once and do it and pass it and then fail another course, if when you're supposed to graduate and you're supposed to get a first class honors, it's going to drop to an upper two. If you're supposed to get an upper two, it's going to drop to a lower two. If you're supposed to get a lower two, it's going to drop to a pass degree, right? Nobody wants to go to the university and graduate. Nobody wants to do any degree and get a pass, right? Nobody wants a lower two neither, no. But at least you can say that you graduated with honors. And that's what I was reminded of, that if I fail this course one more time, the class of my degree is going to fall. And I would not have anything of that. And I'm going to tell you, and I want you to believe this as I speak the truth. That night, I got up at about 10, 11 o'clock. It was years ago, so I can't remember exactly what time it was. And I sat in my living room, between the living room and the kitchen, close to the food. And I sat down, and what I could not do in one semester, I did in one night. I was able to read from cover to cover my textbook and read and understood what I read. And went to school the following day and said to my classmates, especially the ones who had done the course before and failed, I said, guys, the course not hard enough. I now see what the course is all about. And them say, really? Them say, all right, come. We're going to have a study group later. I said, sure. And I was invited to come and teach the class. And a group of us went together over to Chancellor Hall and we sat down and I taught the guys. There was one area that was fuzzy for me, and I told the guys, I confess, I say, you know what? I read it, I understand it, but I can't make the connection. And one of the guys say, yeah man, me know the one day. So when you don't teach this, me will teach you that. And I said, okay, sure. And I would have you to believe me that I taught a group of guys and girls too, this stuff. And them said, blow, trust me, you're better than the lecturer. And when it was a time for them to teach me, the man them tell me, say them don't have time. And them gone. And I said, okay, don't worry about it.
That's
You know,
sad.
no, and I'm going to tell you what I'm saying. And I'm saying this because I don't, this is for somebody in this class tonight.
Mm.
And I said, don't worry about it. Because it's the time it took me what I read in the morning to come into to UA to teach my classmates, it caused me to remember, to solidify what it is that I learned. And I was able to remember the stuff. And all I did the following night was to get up and read the other chapter that I couldn't find out for myself. Suffice it to say, this was in like the first couple of weeks of the class. And all I did was just continue to read in the book. The same thing I'm talking about. You can't do everything one shot or overnight. And I just kept reading the chapters and I kept going over the things that I know. It's when I went into that exam and I saw the questions, I was like, but we can't answer everything on the paper. I may start to laugh. I may say, okay, but it was a difficult course. And
So
when I,
what reached me?
well,
I reached me in a pre-calculus, sir. I waited until it was almost exam
you
time.
can't do that. It's the
You
same
see
thing I'm
me?
talking about, Christopher. It's the
Then
same thing I'm telling you about.
I'm gonna decide for do this time around.
Get the head start.
Never happen.
Never happen again. Chris,
That
I'm telling you,
never happen.
you see, when I went into that exam, I could answer all of the questions. And I said to myself, okay, think about it, Shand. which question you have most information about. And then the days that we had to write 3 questions in 3 hours, an hour per question. And when I finished, it was a very difficult course. And when I finished that exam, I knew I passed the course, but guess what? I will tell you because I really want to find out how real this thing is. At the end of the day, I got a C plus for the course. But I'm going to tell you that C plus felt like an A. You couldn't tell me
Because you work hard for it, sir.
me to tell you, man. But guess what?
Yeah, I know that
Some of
feeling.
my same friends who failed the course the first time and I failed it ended up failing the course again.
Them too selfish, them get to them forget, sir.
No, no, it's not even that, I'm just saying to you, the course is difficult. You have to put the legwork in from early. So when they came and told me that it has a high failure rate, we never paid them a mind. So I'm saying to you, my students, please, the business calculus is not difficult. However, there are some students who wait, just like Christopher said, for the last diggy moment.
Now go work, you have to practice from
You
now.
have to practice from now. So those of you, we still have time. We still have time. We don't have much time, but there is still time. And I'm going to say to you, students, if it means that we start from today, in today's class, tonight's class, if you're going to start from tonight's class, it is a good time to start. You know why? It means that when you're revising, you don't have to revise this one. When you're trying to learn what it is that you missed, you don't have to learn this one because you turned up for class tonight and you paid attention, right? It goes for all the other courses you're doing. For those of you in the bachelor's, please don't play with it. For those of you who are completing the associate degree, please don't play with it. Learning is fun. And when you learn and you share with your classmates, it becomes even more fun. So I'm going to encourage you, for those of you who are pussyfooting around completing the work, get up.
What kind of food?
Catty.
Cat 14. Okay.
Yeah.
Okay.
So I'm saying to you, please, students, I beg of you, it is not difficult. It just comes with a little sweat. And once it is that you can put a little sweat to it, I promise you. If I cannot motivate you, it means that my teaching is in vain. And I'm saying to you, this is something that I have proven. Remember, so I have to do this to you, yeah, man, just do what you're supposed to do, no, man. And once you do it, you're good. All right. So that is enough of my motivating
So you never teach when you were working, like most of us in this class. I say all of us in this class. You just went to school straight. So it's kind of more harder on our path.
Okay, so you are assuming that I went to school.
So you did your degree going to work and school at the same time?
Okay, so thanks for asking. I actually had a part-time job, yes.
Part-time job.
I was studying full-time.
Full-time job.
I was studying full-time and had a part-time job. And Jay, I did the sciences and I had a lab class every single day. One day I had a lab class. On a Wednesday, I'd have 6 hours of lab. And on other days, I'll have about 4 to 6 hours of lab for the other days, right? But the point is, though, Jay, the point is, I could say to you, yes, even though I was working, it was a part-time job and going to school full-time. But I have been back to UA on other occasions where I was working full-time and studying full-time. And I'm going to tell you a secret, final secret I'm going to tell you. The grades that I got for my undergraduate degree pales in comparison to the grades I got when I was working full-time and studying full-time. You know why? Because I know I had to put more work and more effort inside of that. And I paid the school fee, right? So I got better grades. When I say better grades, I graduated at 3.7 something out of 4.
It's the drive, sir. You can't afford to fail the drive. I know that drive, sir.
And think about it, Marky, I'm not as bright as the others. People graduated 4.0, but I was able to graduate at 3.7. You're on that 3.7 plus, 3.75 or 7, whatever it is, I don't remember, right? But the point I'm making,
let me interject. Was the 3.7 consistent over the period of study?
Yeah.
Why?
Um,
Do me wanna drop off a farm with some of them teacher, yeah, them not nice.
Stop it. Stop it. The truth, JD, is that in the last studies that we were required to do 10 courses. And trust me, there were 10 heavy courses. It's like 10 times 2. And of the 10 courses, I got 7 A's, 1 B plus is that 1 B plus and 2 B's, right? And that's why I got the 3.7. So I was consistent. So every semester,
So that again, sir, how much B and how much A?
7 A's, 1 B plus and 2 B's.
Oh, I mean,
And I felt embarrassed getting those
yeah,
B's.
one B and it make me something look bad.
Right. So
It
but
make me something look bad now.
once you get a B, it's going to drop everything. So think about you getting a C, what it does to it. So I'm saying to you, you have to really work. So so one of the things that you need to do, guys, is just be consistent, man. Just put in as much energy. So for example, JD, you're doing a course that you're not too light, but you know you're gonna pass the course, and you're doing business calculus that you absolutely love. Try and make sure say you get um like a 80 something percent in the business calculus, and try and get even a B minus in that one. So when them average those off, at least reach a 70 something percent. And that's what I had to be doing when I struggled with those, with that 1 B plus and 2 B's. I mean, I just never have any interest in those 2 courses.
That's the strategy, sir.
That's the
Because,
strategy, right?
right, but then again, when you do get the B, it still drop the scores significantly. Why I
does.
said that? I got my first three grades first, and then I get the last grade. It's something job to. We can't even say how it was. I mean, not like that. We need to call the teacher and say, what happened? What did you get? Why did you give me a B?
Yeah, the B's is
And,
if you're getting
and I like
the
it.
A's,
And I thought
especially if
I
you're
did
getting the
well.
A's.
You know the
Yeah,
thing
man.
about it, sir.
Yeah, that is the thing. And it
Well,
was
yes,
done.
you
It was done in
put your mind
COVID
to
time.
it,
Was it done in COVID?
sir. Yes,
Yeah,
sir.
yeah.
But the honesty is still there.
No, I'm not
The
talking about.
honesty is
No. I'm
still
not talking
there.
about. I'm not talking about the honesty. You know, what I'm gonna say is that I'm trying to open this. What I'm saying to you is that uh, I have some students that called me into. You remember last week Thursday when I told you I was meeting some students?
Yes, sir.
Yes,
Right.
sir.
They were, and I came to class about 9 minutes late.
Late,
I was,
sir. You wouldn't stop talking about it, sir.
yeah, man. I was speaking to the bachelor students that I'm teaching now, and it's just that their grades were released. I can't tell you what it is now as we're talking about it. Their grades were released, and they called me into a meeting as the head of school and I said, "What is happening?" And fortunately, I taught them a chemistry course, so I had the scripts, and I too had my concerns. So I said, the question says X, Y, Z, and there are students who, for 10 marks, got 0 out of 10 because the students just cannot write. They cannot write. And I'm saying, not because why is this thing not opening? Not because you're doing an online exam, students, and I want you to hear me out. Not because you're doing an online exam or have online accessibility for your final exam, it means that every paper you write, you're going to get an A. It doesn't mean that, because what you need to do is to interpret what the question is saying, and to be able to not to plagiarize, and just to answer the question and make it your question instead of somebody else's question. Meaning, don't write until what somebody else said. Personalize the question so it is that I can understand and say, boy, this student truly knows what he or she is talking about. So when the students in the class pass the course, but they're passing the course with C's and them complaining about them GPA, I said, okay, this is it. And the students were saying, sir, how would you answer the question? I said, thanks for asking. And I told them what I was looking for. Them said, sir, honestly, why never write the question a different way and tell what to ask? And I said, I can't. This is at the bachelor's level. So the degree that we are going to give from Excelsior has to be the same level degree that the UWI students are getting. So we have, and I'm saying this to you because it not only affects those bachelor students I'm teaching, but it also affects the associate degree students. When you read a question and it says to explain or to discuss, you write 2 sentences and expect to get, and the question carries 15 marks, and you expect to get 15 marks so that they do something there. Look at it, look at the pros and the cons of something, and then you develop your argument around the matter and you truly discuss it. take a position. If the question asks you to take a position and you discuss, you expound on something and you tear it apart. Don't just go and say, according to Shand 2021, his view on corporal punishment is that the police has no right to cut the woman pitney here, the dreadlocks pitney here, and them say she should lose her work and the pitney must sue the government and get $5 million. Done. No, we want
Sir,
to. Sorry, go ahead.
sir, do you think that because of this whole online thing, teachers or lecturers are now marking a bit harder?
Um, I don't think so. Well, for me, no. But
Because there's
because
assumption, there's assumption that you have access to either notes or the internet, and so you have to come correct.
no, it's
You
exactly
mentioned the
this.
fact that we have it easy according to them.
No, it
Mr. Them ring that in a the meeting, in a the class, make it third for year that like for years there. You have access to the notes, you have access to the internet, you have, so what? Your persons don't actually study and try to memorize what you have taught them in class and they use it as the information as side sources.
yeah.
Then
All right. All right. So the final point I'm going to make before I move into. Sorry, quick question. I did the differential of the exponential function already, right? E to the x.
No,
No, no,
not
no.
here.
No,
No.
hold on.
I think a question 18 there, now, sir. So look at question 18 you will know where there.
Okay. Sorry. I'm going to answer that, Christopher, but I just want to know that we're exactly on. So my question number 18, but did I do this? The differential of e to the x?
No, send that to tell you,
Okay.
no, sir. You
Okay.
read this here.
Okay. All right. Take time with me now with this one. You see the thing about it, I am doing, as I told you, I teach a calculus 2 class on a weekend. And these are some of the things that they do. So I just wanted to get my bearings. All right. So Christopher, the truth of the matter is, and JJ, the truth of the matter is, not because you have access to the internet makes life easier. As I said, you have to be able to understand what the question is asking, because I won't give you a question and ask you to define what is risk management, right? I will give you a scenario to say, a company has a financial institution is operating a business, but since COVID, they have been experiencing financial woes, and the risk manager was not diligent in looking at the assets of their clients, and the market crashed, and they should have reappropriate the funds to good performing stocks, but it was whatever else situation as a result of that. Now investors are actually losing money. How, as a risk manager, would you advise the company? Hello, you can't find that on the internet. You will now have to understand what are the tenets of being a risk manager, and then know you're going to be applying. So it's that question is more of an application. But some students will go and copy the question into Google, and Google will show you something that somebody else may ask and give an answer. And what we find is that several people are giving the same answers because it is going from Google. So students are actually not using their mental capacity to think on their own. They want somebody else to think for them. And the truth is, none of you at this point in time, if you told me years ago that I'd have become a teacher, I'd have laughed you to scorn. I mean, I'd have rolled over the floor laughing. All right? None of you know where this life is going to take you. One may say, sir, I know what I want to become. Yeah. But when you apply for the work and them say, I think you'll be best suited for this other position, you think you're going to tell them, say, oh no, I'm sorry, I don't need that job. You're going to tell them, give me.
Good evening, sir.
Hi, dearest. So, so I'm saying to you, what you need to do is learn to apply yourself. Have a conversation with your lecturers to say, sir, miss, may I speak with you one away? How would I answer a question? Going at the past papers and present a question and say, Miss, how would I answer a question like this? And get an idea as in, and or even ask the teacher, Miss, I attempted that question. Um, can you have a look at it for me, please? And let the teacher
Sure.
give you some idea. Yeah, final point and then we'll move. Go ahead,
Yeah,
please.
final point, and then we jump into the match. The reason why I ask is still, I got a note that I was marked down for my APA formatting. And I kind of look at that as, yeah, it is important, while it is important, but you mark me down for my APA formatting.
What course was that?
I think it was some ethics class or something like that. Don't you remember? Or was it HR? It's one or two. One of the two.
All right.
That sound like ethics.
I think it is HRM, Chris.
I know ethics,
Ethics that.
ethics, a peer B.
But the thing is, I
Sorry.
don't think she understands APA 7 because APA 7 we use, and she has said about the APA formatting. I'm gonna follow it to the T. You see what I say? So I don't think she really understands about that.
I think some of the lecturers are probably still using the 6, right?
Yeah.
Because when I look and I saw that as a result of the markdown for that, I actually ended up with a B+. And I'm like, what? When everything else I say A, now that my thing was almost 4.0, somebody vexed about it, sir. So
Don't worry about it. Guess what? Just get your A for this course.
I know
trust me,
him
it will go back
alone,
up.
sir, because me get the same B plus too. I
Never
born me
mind.
to see.
Yeah, I had the same thing.
Never mind. Guess what? B+ is not a bad grade. Congratulations. We are going to get it. All right, let's go. So I'm still doing what you call it now. Stationary points. I'm still doing stationary points with you. But as promised, I'm going to go back a step, at the start of each class, and then I go forward. Now, the step that I'm going to go back, you already have this document. The step that I'm going to go back is to look at the square root function. Is to have a look at the square root function. This is a recall from pre-calculus, but I'm going to look at the square root function, and then from the square root function, we are going to be applying our differential, which is pretty much consistent. So differentiation is consistent. I'm just going to show you a little variation to it. So we're looking at the square root function. Now it says whenever you are presented with the square root function, first rewrite the function raised to the half power. So you see the square root sign here? The square root of x, it means that it's going to be x to the half. The square root of x is going to mean it's going to be x to the half. Now, let me do a recall for you. Recall. Oh Jesus. A to the All right, so recall from pre-calculus, the root of a is a to the half. All right, no, that's not what okay, yeah, it's a to the half. And then I can also give you a copy. I can also give you the root of a. Oh, sorry, that's why I couldn't get it, because I have to use the other one, this one, good. All right, got what I'm looking for.
right.
So look at it. I'll come into you. Let me delete the first one because I found the function that I'm looking at. So generally, the nth root of a is equal to a to the 1 over n. The nth root of a is equal to a to the 1 over n. Sir, we get the nth root. The n is in the sleeve of the square root sign, so it's going to be nth root. So whatsoever in the sleeve of the square root sign, you're going to reciprocate it as a power here. The nth root of a is going to be equal to a to the 1 over n. Similarly, the nth root of a to the m, and this is a law from pre-calculus. Similarly, the nth root of a to the m is going to be a to the m over n. The nth root of a to the m is going to be a to the m over n. What's the point I'm making? You notice, let me just do a color code here. Let me do a color code here. No, not you. All right. So I have a color code here now. So if you look carefully at what it is that I have, this here is the nth root of a. Now you see that the n is located in the sleeve of the square root sign. It is located in the sleeve of the square root sign. Now, where is the position of that n? It now becomes the denominator of the fractional power. It becomes the denominator of the fractional power. Similarly, the n is still in the sleeve of the square root sign, but what is under the square root is being raised to a power. Just allow me to write this as a breakout copy, just to bring across the point I'm making. A raised to the m, a raised to the m, raised to the 1 over n. All right, watch me now. So, yes, please.
Remember to save as you go along, all right?
Thank you, Papa. You know, what could I do without having people like you in my class? Thank you, son. All right, look. So, really appreciate that, man. All right, so look at what happens here. So this is the nth root of a to the m. The nth root of a to the m. See here is a to the m that is going to be raised to the 1 over n. Oh, sir, I see it, because I'm treating all of this as a in this case. The same n is in the sleeve of the square root sign, so it now becomes 1 over n as a power. And again, sir, the n is in the sleeve of the square root sign here, so it becomes in the 1 over n, the reciprocal of the power, right? And there's a law that says a to the m raised to another power, you just multiply these two powers. So m times 1 over n is m over n. All right. So this is what you would have learned in pre-calculus. This is what you would have learned in pre-calculus. Now, you may say to me, sir, then what is happening here? Just allow me to you know, every time I teach something else, I won't say I get better at it, but the explanation becomes a little clearer. Now, it is redundant for me to do this, so I'm going to put that in a very pale color so that it can hardly be seen. Can you see that? What is there? Look right here.
When you say
Not true, sir.
Very good.
About
Okay.
the thing, what is
It's really pale.
So, sir, that color have to change, please.
No,
Yeah, too pale, sir.
No, I don't want it to change.
But
The
sir,
point
we
is-
are visually challenged.
All right.
point you're trying to make is that it's not going to be seen.
It's not. The point is I don't write it like it's like me saying the rain is falling. It's like me saying reverse back. It's like me saying repeat again. It's a redundant. So you don't really. If it once it's a 2, you don't write the 2 in the sleeve of the square root sign. So I don't want to make the mistake and put it there so that somebody see it and go and write it. So I'm gonna let it stay. If it's gonna pose a problem.
All right,
If
sir.
it's going to pose a problem,
sir, the
Uh-huh.
magical one that we used to put in blue,
Mhm.
that little light color blue, that we understand the magic stuff, sir. But we
Yes.
can't see the magic on, I can't see the
Mm-mm.
magic on this, sir.
But guess what? No man. Me no want this document go out and somebody go say, what a foo-foo teacher, right?
Okay.
So it is just to bring across a point. So I'm gonna let it stay there. Or I'll put it back without
Sorry,
nothing
look
in
at
there.
7. Missy, 1 second. It looked like a 7. Sir, me trying to challenge you now, sir.
All right. So look at the point I'm making. There is an imaginary tool in the sleeve of it. So when you're not seeing a number in the sleeve of the square root sign, like up here, so you're not seeing a number in the sleeve of the square
Just
root sign,
assume the 2 is there.
you're going to assume that there's a 2, right? So just like when you're doing logarithms, and you say log 25, you're going to assume that the base is base. When you don't see a base written for logarithms, you assume it is base what? What's the universal base?
It's 1,
No,
0.
no,
Hold on.
8, sir.
no.
10, sir.
Will
It's
pass
2,
pre-calculus?
sir. It's 2.
No,
It's
it's 10, it's 10, it's 10,
10,
it's
sir.
10.
Just for argument's sake, I said 10.
10, 10, 10. When you're not seeing a base written there, you assume base 10. Your calculators are
yes.
calibrated to base 10.
So you have to see with me now. I also teach you pre-cal, you know, the man they just run through things.
All right, never mind. Come on, let's go. So what is happening right here, so now, is that there is a tool that you know is supposed to be in there. And I'm putting this tool here very pale, not change it. Matter of
Even
fact,
gray, sir, even if it's a gray area, sir, we can understand that. But I minimize the screen now and I don't see no 2 there. I promise you.
never mind. You know this a teacher
I
ever
think
do?
if I will make such an issue out of it, there's no way I can forget now that the 2, once you don't see nothing there, a 2 is there. I think it is ingrained. It's
Can
ingrained.
you just allow sir to continue, please?
No, I am taking it out. I'm taking it out. You're taking it out. You know why? Because we don't want the document to go out with it like that. So there is just, you know what I'm happy about? Is that I put a 2 there a while ago and the rest of you would have seen that, sir, they put a 2 inside here. So never, ever write a 2 inside the sleeve of the square root sign. Why, sir? Because it is assumed to be a 2. And I don't want to go through that because that could have been developed from pre-calculus. I don't want to go through that to show you why the 2 is there. If the number is greater than 2, then we must write it. But if the number is exactly 2, we now write it. All right? So now, based on what it is that I would have put here, the nth root of a, if n is 2, is going to be a to the half power. The nth root of a to the m is going to be a to the m over n. So any number that is going to be right there. So look, the blue is in the denominator of the fractional power. It's in the denominator of the fractional power. It's in the denominator of the fractional power. If you can remember that, you're good to go. So watch me now. So we're looking at the square root function, you know. We're looking at the square root function. So y is equal to the root of x. Y is equal to the root of x. So I'm going to let y be equal to x to the half. Sir, how you get that again? Because I'm going to assume that there's a 2 inside here. So then I'm going to remove the square root sign. And then I'm going to put x raised to the half power. Remember, whatsoever is in the sleeve of the square root sign is going to be reciprocated and be placed in, let me write it.
And be placed as the denominator.
No, power.
Sorry, yes, power. The power of the denominator power.
Denominator power. I know what you're talking about, but not, you know.
Yeah, that's all right, see me.
Yeah, yeah. Please note whatever is in the sleeves of the square sleeve sign. IGN. I can see AP about reciprocal. People that we are. All right. So please note, whatever is in the sleeve of the square root sign will be replaced as a reciprocal power, meaning that you're going to reciprocate it and put it in the power. Just remember that. Watch me now. So now we understand all of that. We have the root of the root of x. The root of x is going to be x raised to the 1/2 power. That's all that there is, This is this line here. Let y equals x to the half is the new stuff. Everything else you already know because I would have taught you everything else. But nonetheless, let me go through the rest of the question with you. But I would have taught you it. So the only thing that is new for you is the conversion of the square root function into a workable function. And the workable function is to rewrite it here. All right, let's go. So it's going to be a half, see it here, so x to the a half minus 1, which is going to be x to the negative a half. Remember, we're using the power to multiply what is in front of here and reducing the power by 1. So it's going to be a half, bam, times what is here. See it here, so this is a half. So this half up here, so is the half that comes right here. And then now I'm going to have a half minus 1, and a half minus 1 is negative a half. A half minus 1 is negative a half. All right? So the differential finishes right here is just for us now to do a little bit of housekeeping and just try to get the function in a presentable manner. Remember, we math people are positive thinking people. We don't leave our powers as negative. Never, leave your power as a negative power. Always convert it to something being positive. So therefore, again, what? Note. Let me just say what I go. Okay. Copy is a raised to the negative n is equals to 1 over a to the positive n. All right, look at that recall. Note, a to the negative m is going to be equals to 1 over a to the positive m. So remember, and this is pre-calculus again, right? And again, now you can see why it is important for pre-calculus to be the prerequisite for this course. Let's go. A to the negative m is going to be equals to 1 over a to the positive m. So we never normally write our answer as a negative power. We never normally write our answer as a negative power. What we do, we find the reciprocal of it, of all of this, to convert this negative power into something that is going to be positive. So a to the negative m is going to be equals to 1 over a to the positive m. Watch me now. Consider this x as a to the negative m. So the m is going to be a half. So it's going to be now 1 over x to the positive 1/2. See it right there, so 1 over x to the positive 1/2. You know what I'm doing? Let me do something here for you because I want you to see exactly what is happening, guys. I don't want you guys to lose it. So let me just do something here quickly. And oh, stupid, I didn't have to do that. Come on, don't do that, Shoshana. Copy. Paste. Put it back. All right. So look at what Sir Shand is doing here. So what Sir Shand did was to say, this half is the same thing as this half. And then now you notice that this half is being multiplied by x to the negative a half. Talk truth. Everybody can see that? That this half is being multiplied by x to the negative a half?
That's one of the first things I noticed, that when you brought it forward, you put it in the front like when we were differentiating earlier, and then
Right.
as a negative half. I'm like, a half is a half, a quarter.
Right. No, but I mean, but but my point though is, can you agree that this half is being multiplied by x to the negative a half? Do you agree
Yes,
that
sir.
this is being multiplied by this? That's the point I'm asking.
Yes, sir.
Agree?
Yes, sir.
Okay, good.
Yes.
So that's why I put in this multiplication sign here to bring across a point. I'm putting this multiplication sign here because I want to bring across a point. Now, I am moving from here to here, but I'm telling you what I am doing inside here.
Sir, put the note in a different color.
And I have no problem with
Just
that.
to make it clear, you know?
I have no problem with that. You see, your teacher takes suggestions from you. You know, this is a phone or something I do with phone. You know, I am at your. All right. Matter of fact, I even embol it. All right. Watch teacher now. So note, a to the negative m is equal to 1 over a to the positive m. So this is just to help you with the conversion of this line here to what it is that I'm doing in the middle part here, to the point where, based on what Emilia said a while ago, I'm going to put this in another color to show you that inside of the middle piece here, so it's just a little working out before I get to this piece here. Watch me. This a half is this 1/2 right here. I'm converting this x to the negative a half. Remember, a to the negative m is equals to 1 over a to the positive m. So x to the negative a half is going to be equals to 1 over x to the positive a half. Talk through. Do you see it? Do you agree with this?
Yes, sir.
Anybody in the class don't see it? All right, let me press pause right here. So,
Jenny.
Jenny.
We see it.
No, man. We know you see it. Rashid. Unmute for me, please, Rashid. Rashid. Unmute for me, please. Ricky, see it?
Yes, sir, I'm following. I'm getting this one.
Nice. So Tanya, are you seeing it?
Sir,
Yes, please.
where you put the purple ink, the answer that you have here, we multiply those. Yes, I see that, but what's below it, sir? That's the answer for it?
This piece here is the answer, but hold on there. 1 minute. I'm coming to you. Rashid Bennett, can you unmute for me, please? McCain, are you understanding? Boy. Sidonie?
Where did you call my name?
Who is that?
Jennar.
I'm asking if you're understanding, Jennar. Are you understanding?
Oh, sir, I am not 100%, but yeah.
Rashid is typing in the chat, sir.
Yeah, me answer him. All right. Okay, so Tanya?
Sir.
Yes.
Sir, right now, me feel like not even Compass can find me the way me last.
And why think we stop the class? You think you're idiot? Why think we stop the class with Tanya? I know, that's why I stopped the class. That's why I stopped the class anyhow. We will talk. That's why I stopped the class, you know. Because I know I a long time I teach, you know. So I know. Vanessa?
Sir, I don't know if it's because I'm using my phone, not for the class, but me not grasping.
Do you have a tablet or a computer?
Sir, something wrong with my laptop keypad, so the number's not giving what it's supposed to give. You touch M and you get something else.
You have to go start that out, you know, honey.
Need a new keypad, baby.
You might have to go start that out, you know. You have to go start that out and start it up. Quick time. Ophelia, are you following?
Sir, I was following a while ago and you were going through, but just that. Sir, I was late, you know, and that a few minutes ago.
Okay, all right, cool. Sidonie, are you following?
Yes, sir, I'm following.
Okay, thank you. Tamoya, are you following? Tajay, or you stay?
Sir?
Or you stay, Tajay?
Sir, I like if you go right one more time, stay, but I'm following now, yeah.
All right, cool. Vanessa, how things?
Sir,
Don't laugh
I'm
at me now.
following, but to
Vanessa,
understand, it not
Vanessa,
connect.
sir.
Vanessa,
Yes,
we're
sir.
going to fight, you know.
I'm following.
And it's where fight is one of two places we're going to, either in church in front of the minister or in the police station in front of the popo. All right. No, let me stop. You can mute, honey bunches. You can mute. All right. Students, hear me out. You see, if you say to me, sir, I am not understanding, don't think that I'm going to get annoyed. Maybe other teachers get annoyed. But you know, when I get annoyed, when I discern in my spirit that there are students in the class that are not following, and I'm teaching and have to stop to call upon students individually, and then I'm hearing the truth. I want you to be truthful. You see, in a relationship, we in our relationship, you know, we want you to talk the truth. Talk to me. Sir, I am not understanding. Can you do that one more time for me, please? Don't make me one alone sit down and enjoy myself. Because I'm telling you the honest truth, I'm enjoying myself. This is my bread and butter, so I love it. And you notice what I'm doing? I have the tablet with me, but I refuse to write on the tablet because I want to type it so that when there are things that I can recall, I put it there so when you're reading over stuff, you can see it. And that's why I use this methodology with you. The other classes, I take up the tablet and I write. My students, talk to your teacher. Me, I give you permission to talk to me. Talk to me. Please, you know, understand something? Say, sir, we're not following. Let me say, Lord Jesus, Christopher, how much time have I tell you the same something? Let me say, Christopher, talk to me outside of class. And trust me, you'll never hear me speak negative to any one of them like that. No, man. Me feel a way when me not talk to teacher, man, and I don't understand. Talk me, man. I say, sir, hold on there. Mark, you know. Let me not say that. Let's go. Let's go. Let's go. Let's go. Come on, guys. Let's go. So you're given a function. The function is y equals x to the, sorry, y equals the root of x. What it is that we're doing is looking at the square root function. We're looking at the square root function. I said whenever you're presented with a square root function, first we write the function raised to the half power, right? And okay, fine. That is x to the half. So I'm going to recall now to say that the nth root of a is going to be equal to a to the 1 over n. The nth root of a is going to be equal to a raised to the 1 over n. Similarly, the nth root of a to the m is going to be equal to a to the m. The a to the m here is this, raised to this 1 over n. Oh, sir, I see it. Because the n is in the sleeve, it's going to raise to the 1 over n. Yes. Because the one here, sir, may I follow the one here that says, may I follow the one here, sir, that says a to the m. The nth root is the same as 1 over n, and the nth root again is the same as 1 over n. Yes, man. Any number we drop in at the sleeve of the square root sign, I'll go raise to the power, but me I go reciprocate it. See here? It says, please note, whatever is in the sleeve of the square root sign will be replaced as a reciprocal power. So it means that I'm going to replace as a power, but me I go reciprocate it first. All right. So if this was the fifth root of a, it is going to be a to the 1 over 5. The seventh root of a is going to be a to the 1 over 7. The 100th root of a is going to be a to the 100. A to the 100. I'm in a class and I don't know who is this calling me. Right. So it's going to be any number in the sleeve of the square root sign. Now go put it as a power. But before we put it as a power, again, reciprocate it. So I call it the reciprocal power. I'm going to reciprocate it first and then put it as a power. All right? All right, so watch me now. So I'm looking at some examples and I'm differentiating the following. Watch my examples. Y is equal to the root, the square root of x. What I'm going to be doing is, remember, you know, when you're not seeing a number in the sleeve of the square root sign, you're going to assume the number 2. Right. Yeah, very good, Marie. Yeah, assuming the number 2. So therefore, this is going to be x raised to the 1 over 2. Because any number in the sleeve, watch it up here, so any number in the sleeve of the square root sign is going to be in the denominator of the power. Because you're reciprocating it. Reciprocate meaning you put in 1 over. All right? So let's go. So this 2 here, sir, I'm not seeing a 2. Yeah, it's imaginary. It's going to be 1 over 2. Then now I'm going to be differentiating. Should I remind you of the differential? So fast, me I go through the document if it will freeze up on me. Oh boy. Yes, I where am I? I'm not seeing. Where is it? Okay. Copy. And you all have this copy of this document, so you don't have to worry about it. Where am I? An information. Sphere function.
Sir,
Yes, sir.
sir, just to point out, you didn't go over the logarithms with us.
Yeah, man, I know that. Those are the 2 extra stuff that I needed to do with you, the explanation and logarithm. But thanks though.
All right.
You know what? Let me put this as recall outside here. So, all right. So, recalling here that y is equal to x to the n, for those of you who are not following, but free to talk to your teacher, y is equal to x to the n. So when I'm differentiating, it's going to be this n that comes in front of this x. See it right here, so? And then I'm going to subtract 1 from the power, so it will become n minus 1. See it right here, so? So this is a general rule for your differentiation. Y is equal to x to the n, dy by dx. The rate of change of y with respect to x. Dy by dx is going to be equals to n x to the n minus 1. See it right here, so? All right? Now, so that's what I'm going to do between right here. I have y to be equals to, oh, I'm not going to tell me sitting in the wrong position. All right, so this is my differentiation. So I reach this line now to differentiate. So watch this. This is x to the n. The n will come in front of here, so it's x to the half. The half will come in front of this. See it, so the half catch in front of it. See it right here. So the n is in front of the stuff. The half catch in front of it. Then the n is going to be n minus 1 because I'm reducing the power by 1. See it here? It's going to be a half minus 1. And a half minus 1 is going to be equals to negative a half. And that's why I get this negative a half here. All right? Now, a to the negative n. A to the negative n is going to be, yes, please.
1 minus a half minus 1 is
yes,
a half.
Every time.
A 1 minus half is a 1 and a half minus 1.
Look at this. You tell me. Look at this. It's going to be
a negative half, you know, Marie.
You see, it's going to be n minus 1. But in this case, n is going to be a half. So it's going to be a half minus 1.
Which
so
give a negative half.
A negative a half, Marie. You see, mommy?
Okay.
Come on. Very good, though. So it's going to be negative a half. Watch me now. But remember, the story says, whenever you have a negative power, we positive math people don't write our answer as a negative power. We always convert it to something that is being positive because we are positive thinking people. So anytime you see a to the negative m for argument's sake, we're going to reciprocate it and put 1 over a to the positive m. 1 over a to the positive m. Now we're making this positive power. And similarly, because the equal sign, it goes both ways. If I have a to the negative m and I want to do something, I can flip this to the numerator, but the power sign will change, it will become a to the negative m, right? So you get back this down here. So let's go. What am I saying here is this x to the negative a half is going to, this half rather is this half right here, so. And x to the negative a half is going to be 1 over x to the positive a half. See it so? Because I use this something here, this and this are the same thing, you know, right? X to the negative a half and a to the negative m. A to the negative m is 1 over a to the positive m. X to the negative a half is 1 over x to the positive a half. So this is where I was before I started the class. All right, watch me now. This is being multiplied by that. 1 times 1 equals 1. 2 times x to the half is 2x to the half.
So small, and what is that about it not being negative again?
This because it's now in the denominator, it's now positive. Okay. See here, sir? This m is negative. Talk through. Do you see that?
Yes.
Good. And then no, because I reciprocated, it now becomes a to the positive m. A to the positive m. So this is why this becomes a positive a half. The only reason we reciprocated it is because the answer, the power, was negative. We don't deal with negative powers. We convert all negative powers to positive results.
Can you just make a notation right there to say reciprocated to convert to positive, or that, you know?
Always will always a out of a when always are in C and P out of C. Always reciprocate. Always reciprocate. Get a positive result. All right, every time. All right. So what happens now? This x to the half, blow, oh sir. We know that the root of x is equal to x to the half. So we're going to reconvert this x to the half to the root of x. So see here, so this x to the half is going to be reconverted to the root of x. So our answer now is going to be 1 over 2 the root of x. Sir, you couldn't read the answer as this. You see, because I gave you the question as the root of x, and we bright enough to convert it, we have to leave our answer in the form that they gave us the question in. We have to leave our answer in the form that they gave the question in. So your answer there is going to be 1 over 2 the root of x. All right, let us go through with this question. Let us do this question. And I'm going to work this question with you, and then I'm going to give you a question or two to do for me in the meantime. Let us work this question. And because I know you have this document, I don't want you to just go and look at the answer of the document and say, yes, sir, I get the answer. It means I'm going to write a new question. Like put one question 4 right here, so, and then write the question right there. Eh? Let's go. Y is equal to the root of 2x plus 3. Sir, easy. I'm just going to put 2x plus 3 to the half power because there is no number here, sir. So we're going to assume the number 2. Do you agree?
Yes, sir.
Yes, sir. Can I ask a full question?
Sure, no problem. Go ahead.
Can you just scroll back up to the first question there? So what happened to the half right there?
This half?
Yeah.
All right. It's reconverted to the root of x. See here? The root of x. See here?
Oh yeah, I get what you're saying.
Okay, good. All right, let's go now. So 2x plus 3 to the half power. 2x plus 3 to the half power. Watch me. So now I've converted my 2x plus 3 to 2x plus 3 to the half power. Look at what I'm doing. I am differentiating now. So in differentiating, look at what will happen. This half will come in front of this to give it this half here, so. And Marie, I am going to subtract 1 from the power. I'm going to write back this right to say no. So it's a half minus 1 is negative a half. Same thing like what we did before, but guess what? This is a power rule. The power rule. So we now have to differentiate what is on the inside here. The differential of 2x is 2. The differential of 3 is 0. So we have to times it now by the differential of the inside. And then now we say a half times 2 is 1, or 2 halves make a whole. So all I'm left with is 2x plus 3 raised to the negative a half. See to yourself? 2x plus 3 raised to the negative a half. Oh, sir, but you said that we don't write our answer as a negative power. So I think, sir, we have to find the reciprocal of this. Very good. Very good. So we're going to find the reciprocal of that. And when we find the reciprocal of that, oh, come on. When we find the reciprocal of this, we're going to get it as 1 over all of this to the positive a half. Oh, I see it now, sir. So because this is 2x plus 3 to the negative a half, when you reciprocate it, sir, it becomes 1 over 2x plus 3, not to the negative a half again, but to the positive a half. Very good. Then, sir, oh, we see this down here, so because they did not give us the question in this format, they give us a question in the square root format. So because this is a half, I can just put all of this 2x plus 3 in a square root, something down like here, so, and this will be the final answer. Remember, whatever format that they give you the answer in, you have to put that format right here. So, right here, so sorry, right? So this 2x plus 3.
Sorry, if by mistake you forget to put it back in the form in which you find it, we lose marks for that or we don't get the grade. Which is it?
On a good day,
not good.
I will just say, you know what, them exam condition here.
Okay.
But I have to teach you the correct stuff. On a serious note, yeah, man, yeah. So on a good day, I say, yes, Emilio.
I missed something. The way get multiplied by 2. Where 2 they come from again? Sorry.
Emilio, me not tell you.
Yes.
Last week, no. I don't care if you step away 3 times. So last week you said to me, Thursday, you said to me, G's on peace, sir, I keep forgetting to do something. What was it that you kept forgetting to do? Let me see if you remember.
Put back the way you call it, the 2 in front of the x.
No, you kept forgetting to differentiate what was inside the parentheses when using the power.
Oh, yes.
Right, at the same thing, Emilio. So you're still forgetting Thursday, Friday, Saturday, Sunday, Monday, Tuesday. 5 days later, I'm still forgetting.
Yeah. My head a chip, sir. You have to see.
No, man, that's fine. But that's why I told you no a while ago, because I wanted to bring across the point. So
yeah, which is true. You're correct now. So when I differentiate the parentheses, the 3 gone and left the 2x. So it took off the x and left the 2.
Very good. Excellent. Right. Yeah, man. All right. So this is what it is. That's what it is. All right. Now, this one here, by the way, are we okay with number 2?
Well, we're okay with the second question. I'm okay with the number 2, sir.
You can't go about your business. Because we never play number 2, we not even know. Yes, please. Yes, Yana.
Sir, so basically what I'm guessing is that from we look at this, we can guess the answers as well.
Well, guess what? I can guess the answers. Well, not a matter of guess. If I get a question like this, I can tell what the answer is. But if I get a question like this, Yana, I can't tell what the answer is. Okay. So look at what I'm doing, honey bunches. Look at what I'm doing. You notice sir is giving a simple question, and then sir is giving not so much of a simple question, and then sir is getting to what the question will look like. Yeah, sir will get what the question will look like.
Alright, so yeah, tease with image.
All right. No. All right. So let's go. All right, Emilio.
Yes, sir. But I asked me to guess, you know,
no, ask me to guess. No. What method am I going to use to do this question, Emilio? And I don't want anybody to say. I want Emilio alone to answer.
Product rule.
Oh, geez, I'm going to buy you a Guinness. No, I'm going to ask that person to buy you a Guinness. Very nice, Emilio. No, Emilio, yes, I want you to tell the class. I want you to, okay, Dr. Jen, I want you to tell the class, no, Emilio, why is it that it's a product rule?
Powers plus the powers plus then based on how the question is formulated, you'll have to use the product rule to get to the actual way them.
So tell me how me know the question formulate. No, that not help me. Tell me how me can look on the question like you until it says product rule.
You have powers both outside of the square root and inside of the square root.
So say to me then that the 2x to the 5th is being multiplied by the root of x squared minus 1.
Minus 1.
Right.
You said that the maths way, and he's not a mathematician.
I know, that's why I'm trying to get you to that point. So
there are
guys,
2 terms.
No, Ricky Bell that? Or
yeah, man, Ricky,
is that Ricky Bell?
Yeah, man, the infamous by the man name now.
No, man, no, something is happening. No, something.
Yeah, man,
Ricky.
Man, sir.
No, man, I'm gonna tell you, man, be careful, you know, because the boy look like he want to come take my job.
Man, I tell you, Ricky boy come teach class these days. I like it.
No, man, I like it, man. Very nice, Ricky. Very, very nice. I remember, look at me, load you up now, Ricky. I remember the first class, you were so tentative. Ricky, can I unmute from him, sir? You know, like much, you know, you remember Ricky?
Yes, yes, sir. Math was not a favorite subject.
Yeah, but guess what? No, y'all talk up in my class. It was on your call to you. You're so nice, very good, Ricky. Proud of you, and the rest of you, I want to get you to that place. You don't have to be afraid. Talk to me. I won't bite you. I will speak to you. I mean, 1 or 2 times I may rough you up, like I may rough up Amida while I was going to say, "No, tell you." Because he kept forgetting to differentiate on the inside, right? So Emilio, please don't forget. I'm gonna call upon you at some other point tonight. Don't have to be in this class.
Yes,
man.
Yes.
You have to remember this, please.
Yes, sir.
All right, now. So let's go. Good of that. So yes, very good. It is a product rule. It is 2x to the 5th that is being multiplied by the root of x squared minus 1. The first thing we're going to do, matter of fact, I'm going to go through this question. I'm going to leave it on the screen and then I'm going to put a question beside it over here so for you to work for me. So I'm going to go through this quickly, give you a chance to go through it and digest it for yourself and then do a question on your own. So this is 2x plus 5. Now, I am remember, the first thing you do is convert your square root into something that is workable. And because this is the square root here, so it means that it's going to be raised to the half power. So it's going to be x squared minus a half to the half power. So we have these 2 things now. So remember the product rule. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. One more time. The first times the differentiation of the second plus the second times the differentiation of the first. You cannot go wrong if you study that thing and put it to long-term memory. I promise you. I learned that thing years ago. Let me say years ago, years ago. And to this day, that song is still in my head. The first times the differentiation of the second plus the second times the differentiation of the first. Now, what I just did was to write what my first is and what my second is, because to this very day, when I'm doing it, I need to know what my first is and my second is. And because I don't want to get confused, I'm going to write it. So it's going to be the first. Sir, whenever I call the first, I write it back. The first, 2x to the 5th, right back 2x to the 5th. Emilio, can you differentiate this for me, please? You see what I did right here? This a half. Come and multiply to give me this.
Right.
Then I write back this right here, so. Right. Then I subtract 1 from the power.
Subtract the 1.
So it becomes negative a half. Where does 2x come from, Emilio?
They put the power, which is 2, in front of the x, it becomes 2x. And you take away the differentiation of constant is always 0.
Right. So when I differentiate now, the x squared I get 2x.
Oh, yeah, right. And 2 minus 1, if 1, so you know write back the 1. You just write x.
Good. So guess what now, guys? So let us differentiate the second now. So it's going to be this comes and multiplies in front of here. See it right here, so. Then I'm going to write back this and subtract 1 from the power. So this x squared minus 1 is this x squared minus 1. It's going to be a half minus 1, which gives me a negative a half. But it's not yet finished. I have to know differentiate what is inside here. So the differential of inside here is going to be -1 is a constant, which is equal to 0. And the differential of x squared is going to give me 2x. All right, so that's the difference. That's the first times the differentiation of the second. So all of this is the differentiation of the second. Then it says plus the second. So we're going to write down plus all of this. See that, so plus all of that. Times now the differential of the first. When I differentiate the first, I'm going to get 5 times 2 is 10x to the fourth. See here, 10x to the fourth. All right. So watch me. There are two terms. This be multiplied by this, be multiplied by that. So I'm going to multiply the numbers then. 2 times a half is 1. And 1 times 2 is 2. X to the fifth times x is x to the sixth. And this x squared minus that to the half is this number right here. So, and all I'm doing is putting this 10x to the fourth in front of here so that it becomes easier. And this is important. You always factor out the smaller of the two. But sir, the two of them are the same thing. Which one's smaller, sir? X squared minus a half to the negative a half, x squared minus a half to the positive a half. Sir, the two of them are the same thing. Am I correct?
One is the smallest.
No, sir. The positive,
So you have a
negative
negative one. So the negative
Very good.
is the smaller one.
Very good. So this negative sign here makes this one smaller than this one.
Lesser.
Yeah. So at a 1 here, that I'm going to factor out the 1 to the negative a half is what I'm going to factor out because we factor out the small of the two. Always remember that. You know, me at God school, my teacher never tell me this. I used to struggle when I reach right here. So they know which one to check out. And when we start teach, me say, what a man did wicked. Me say, sure, maybe never did know, you know. So you always look at the small of the two. So I'm a Duke still, you know, respecting man in could I teach. So this is x squared minus 1 to the negative a half. See it right here, so? But I'm going to look now and say, but sir, 2 can't go in at 10, you know. So 2 is a factor then, because 2 is a factor of 2 and 2 a factor of 10. Yeah, man, that's why I'm put the 2 right here, so. And then I have x to the 6, and I have x to the 4th. Oh, sir, take the smaller of the 2. So we're going to write down x to the 6. But sir, I put x to the 4th. And x to the 6 is supposed to be right here, so. I should have x to the 6 down. Actually, no, them not answer.
Oh,
The
no,
smaller
sir.
one
It
is the
shouldn't be x to the 6. No,
Why?
sir.
Why?
Because we're taking the smaller one from the smaller x.
Very good. So I just asked you to see if you guys were awake. You hear? Let me soon go boil a tea and drink. I'm going to have to keep awake. Yeah, man. So I have to take the smaller of the two. Remember, the smaller of the two. The little s1. The little s1. All right? So let's go. So, you know, think of it this way. Think of it this way. You know, when you grow up and you have one of your siblings with you, and your father come home and your father got beat, or your mother got beat, who first you catch?
Bigger one, sir.
The older one.
The bigger one, sir.
Not at all.
Oh, the small one.
Are the smaller one?
None of my house.
Chris, you have siblings, Chris?
Yeah, I do.
I mean, no use to get no beaten, you know, so you can't hide that, right? So let us move past that piece and say, when them catch you for beating, you know, who them catch first, the big one or the little one?
Little one, sure.
Or the little one. Because the little one can't move fast like the big one, you know, the big one, them smart to know, say, mama or papa gone, and trust me, you know, you just sit around, you know, and they might catch the pot cover and they might feel it. And people nowadays are talking about child abuse. That's not child abuse. But anyhow, we'll talk about that.
That was
Different
called
places.
discipline, sir.
Absolutely, yeah.
Sir, what you're saying is true because I remember everybody run left me one time and me get all a lick.
Same way. So think of it. Is the small one going get catch? So it's the small one we're taking out. Just think about it. Maths are real life, something, you know. Real
Sir,
life.
you know when I found out that, sir, is the day when he was teaching us something. I think what's the first principle, and you equate it to rice and peas and the season. And I'm like, oh my god.
Same as, no, a real life, man. A real life. All right, look at this now. So we take out the smaller one. Emilia say, lickless. We take out the lickless one, them out of everything first, and then we're going left what is left. All right? Now watch me. Watch me. What do I multiply by? 2x to the fourth to give me 2x to the sixth. These two are the same thing as the 2 here, and this x to the fourth. Let me multiply by to get x to the sixth. When I'm multiplying and the bases are the same, I add the powers. Oh, so in order for me to move from 4 to 6, I have to add 2. Oh, that's why I get x squared, sir. Thanks for asking. Yes. So x to the fourth times x squared give me x to the sixth. X to the fourth times x squared give me x to the sixth. Okay, sir, got you. But this, sir, are the same thing as this one here. Yes. So we don't have to write nothing here, sir. No, because we already have it. Following you, sir. Okay, sir. So we move on to the plus. Sir, what do you multiply 2 by to give you 10? 5. That's why we have the 5 here. But sir, the x to the fourth and the x to the fourth are the same thing, yeah, man. So that's why I multiply by 1. 1 times 5 are 5. Got you, sir. But sir, or you only get, you have x squared minus 1 to the half. How you get x squared minus 1 to the first power? Because when you're multiplying and the bases are the same, x squared minus 1, x squared minus 1, you add the powers. Negative a half plus 1 is positive a half. All right? So that's why we got it. So let me just do something right here so that you can see what is happening. Guys, and this is plan to teach tonight, you know. Jesus, Father, me dead now, you know.
How you plan to teach tonight?
Stationary points.
Oh.
But anyhow, let's go. Okay, Jen, let's go. So this one, so when I add this to this, I'm gonna get negative, positive a half, and then I just gonna fix up this one. So remember, sir said to you, know, once it is raised to positive 1, you can just remove the parentheses. If it is greater than positive 1, you have to go do what it says. If it's square, you have to go expand it. If it's cube, you have to expand it. But once a 1, we can just go ahead and remove the parentheses. Sir, how you do that? 5 times x squared is 5x squared. 5 times negative 1 is negative 5. And 1x squared plus 5x squared is 6x squared. And the negative 5 stands alone, it right there so. You write back all of it here so, and you have this here so. Sir, we finish. Not quite. Because remember, you know, this piece here is a negative. So we're going to put it.
Sir,
Yes, sir. Yes, sir.
You can just go start from the 5, the taking it out of the parentheses again, please.
Sure, honey. You're not the only one that somebody sent me a message to. Hey, you know, you must proud of me, you know. Teacher teach, you know, and I watch the chat, you know. Normally, me not do them someday, you know. No, mommy, I learn, man. I'll probably let me just fix up this 1 minute here. All right, so I'm putting something else inside here. All right, so this point, Yana, or this one?
Yes, sir.
All right, right here. Okay.
Yes.
So what I'm saying to you now is, all right, let me go from a step above. So this is raised to the first power. So I'm going to be distributing this 5 into the x squared minus 1. So 5 times x squared is 5x squared. And 5 times negative 1 is negative 5. And then this 1x squared plus this 5x squared give me 6x squared. And the negative 5 stands alone, so I just put back the negative 5 here. You notice I'm not troubling this, because watch this trick. 2x to the fourth times x squared minus 1 to the negative a half. 2x to the fourth times x squared minus 1 to the negative a half. 2x to the fourth times x squared minus 1 to the negative a half. What you recognize?
Each time you put it back, sir.
Absolutely. So you say once you do the factorization right here, so You care about this something right here, so you carry it back right. So all you're really interested now is in the square parentheses, is what it is that you're going to be working out, just to bring it down to something that is nice. And when we catch right here, so now this piece, we don't leave a negative reciprocal, negative power into the answer. So we're going to carry this negative piece into the denominator so that it becomes positive. See it yourself? X squared minus 1. I'm sure I changed it to the positive a half. Everybody see that? X squared minus 1 to the positive a half. And then now remember, say, because they never give you the answer as to the positive a half, we're going to convert it to the root of x squared minus 1. See it here, so? The square root of x squared minus 1. And all up here, so, is the same thing here. So the only thing I do is change the brackets to curly brackets instead. And if you use the square brackets, still right? So this is what it is that we've done. All right, so I got a request to just run through it very quickly, sir, and I'm going to do just that. All right? So we're given the question, 2x to the 5th times the root of all of that. What I'm doing is converting the square root to x to the half. The square root to x to the half. Having done that, I'm identifying which is my first, which is my second. Remember, when I'm differentiating the product, it's going to be the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second, I'm differentiating this. A half, bam. X squared minus 1 to the negative a half, bam. And Emilio keeps forgetting to differentiate inside of the parentheses. So when I differentiate inside of the parentheses, he says to me, sir, but the differential of a constant is equal to 0, and he's correct. And then when you differentiate x squared, you're going to get 2x. That ends the first term. Then you're going to plus the second, plus this. All of this is the same thing as all of this. Look at it and tell me if you agree. Yes or no?
Yes, sir.
Okay. And then we're differentiating the first term. The differential of 2x to the 5th, 5 times 2 is 10x to the 4th. 10x to the 4th. Technically, my differentiation ends here. Is all I've done here, so, is fixing up. Sir, do I have a fix up? Absolutely. Absolutely. So this 2x is being multiplied by all of this, which is being multiplied by all of this. So me going to take it step at a time here, sir, because me can't say everything one time. 2 times a half is 1, times 2 is 2. X to the 5th times this x is x to the 6th. And everything in this parenthesis raised to the negative a half is everything in this parenthesis raised to the negative a half. And 1, the magical one that is in front of here, is going to be multiplied by 10x to the 4th to give you 10x to the 4th times the x squared minus 1 to the negative a half, which is here. And then recall now that always factor the smaller of the two. I'll look into see what is common. How you find what is common, sir? The base and the base.
Go back to that step before you reach recount.
You step this one?
After that, going down to that one, right?
All right, so this 2 times a half is 1, and 1 times 2 is 2.
Okay.
X to the 5th times x is x to the 6th. And this x squared minus 1 to the negative a half is the same x squared minus 1 to the negative a half. And all that is just rearranging. This 10x to the 4th is where they come in from. And we have x squared minus 1 to the half.
Forgot that step there as well. That's why. All right, cool. Thanks.
Cool. Yeah, man. And then now recall I'm factoring out the lower of the 2. So factoring out the lower of the 2, I'm going to have factoring the lower of the 2. I'm going to have this x squared minus 1 to the negative a half is the lower of the 2. So I'm going to factor it out. I'm going to factor it out. Now, when I factor out the x squared minus 1 to the negative a half, it comes right here. X squared minus negative 1 to the half. It's right here. So 2 is a factor of itself. It is also a factor of 10. So we're looking upon the smaller of the two, So we look on the numbers. This smaller than that one, so we go take it out. Because we know that 2 is a factor of 2 and 2 is a factor of 10. X to the 6, x to the 4th. X to the 4th smaller, sir. That's why the x to the 4th comes out. I am teaching it this way because it makes life so much easier. And then there's nothing else for you to come up because you take out the 2, you talk about the 2, you talk about the x to the 6, you talk about this. So there's nothing else to come out, right? Then you're going to say to yourself, now, what do I multiply by 2 to give me 2? 1, sir. There's a 1 right here. So you see, magical. What do I multiply by x to the 4th to give me x to the 6th? X squared, sir. See the x squared here. What do I multiply by x squared minus 1 to the negative a half to give me x squared minus 1 to the negative a half? 1, sir. The 1 is right here, so 2. All right? So the first something done. Then we're going to put back the plus sign. Then we're going to move on. What do I multiply by 2 to give me 10? 5, sir. What do I multiply by x to the 4th to give me x to the 4th? 1, sir. But we not see the 1, sir. It is magical. All right? Then what do I multiply by x squared minus 1 to the positive a half to give me x squared minus 1 to the negative a half? It's going to be x squared plus minus 1, x squared minus 1 to the positive 1. 1 minute, please. All right. Okay, now. So sorry about that, and let us continue. And then, so what do I multiply? What do I multiply by
Sorry, I have
x
something
squared?
on the screen that is kind of blocking some of the numbers.
What do I multiply by? What do I multiply by x squared minus 1 to the negative a half to give me x squared minus 1 to the positive a half? It's going to be x squared plus 1, x squared minus 1 to the positive 1. Sir, I don't see that so quick. No problem. Thanks for asking. When I'm multiplying and the bases are the same, I'm going to be adding the power. So x squared minus 1 is the same as x squared minus 1. It makes it the base. So when I'm multiplying and the bases are the same, I'm adding my powers. So this negative a half plus 1 is going to give me positive a half. Marie, unmute honey bunches.
Yes, sir.
All right. You were asking the question when JJ answered you.
About
Ashana say answer, sir.
When it on sound like so. When Shauna K answered, you remember we were saying that this when we're subtracting 1 from the half,
yes, sir.
we're going to get negative a half.
Yes, sir.
At the
Because the
same,
one is because the
because we're subtracting one from the power. Yeah, it's a reverse that we're doing right here, so no. It's a reverse we're doing right here, so this negative a half and this one to get this positive a half up here. So I'm multiplying, what do I multiply by this to get this? It has to be to the first power. So it's as if we're doing the reverse of the question that you asked and Shauna can answer is the opposite is the opposite of it we're doing now. But it's the same family. Is you going from home to work and is you going from work to home. So it's the same process, but you just reverse in the order. You get me?
yes, sir.
So remember now, 1 minus a half. When I'm subtracting, I'm going to take the smaller number from the bigger number. So you have a half and one. You're going to take the smaller number from the bigger number. So you're going to say, okay, let me take a half from one. You're going to get a half. But you're going to keep the sign of the bigger number. Which other number is bigger? The one. Which sign come in front of the one? Minus. So your answer is going to become negative a half. So it goes anyway. So if you say, what is 3 minus 10? You take the smaller number from the bigger number. So 3 from 10 is 7. But what sign, where's the bigger number? 10. And what sign come in front of 10? Minus. So the answer will be minus 7. So whenever you're adding, and the signs are different, always subtract the smaller number from the bigger number and put back the sign of the bigger number. Every single time it works. Every single time. Okay. All right. Now, and then now, we just go ahead and do the x squared. Because this is raised to the first power, we can remove the parentheses by saying 5 times x squared is 5x squared. 5 times negative is negative 5. Had this been a number greater than 1, you could not have done that. Had it been a number greater than 1, you could not have done that. So we're going to have this x squared plus 5x squared. You notice that I'm not even touching here, so because a linear are the same thing as a linear, same thing as a linear. They're all the same. It will not change. Why, sir? Because this is your factored quantity, right? So you know, so simplifying all up here. So it's going to be 5 times x squared to give you 5x squared, and 5 times negative 1 to give negative 5. You know what I can pause and talk about? Some students only use this 5 to multiply by this x squared and then write back the negative 1. That don't make it.
Repeat that, please. Repeat that, please, sir.
I'm saying some students will use this 5 to multiply the x squared, but will not remember that this 5 is going to be multiplied by this negative 1 also to give you negative 5.
Oh.
So you have to, yeah, man. So you have to distribute. You have to distribute the 5 over the parentheses. Distribute the 5 over the parentheses. All right? And then now when you add 5x squared to 1x squared, you're going to get 6x squared. The negative 5 stands alone, so you can put back the negative 5. And pretty much, hold on there.
See, I don't know about everybody else, but it's always a factorization part of this thing that's messing with me.
So it's the fact because the other day we come like me get to a sir that say, and when the time come now for me try the one, remember the one with the 500 and something.
Yeah.
So add up so that thing get 500 and something. Me no know what. I know when sir start again, me kind of get an understanding of it, but you know when we ready to start.
Sorry about that here, guys. Online teaching has taught me to become an Englishman. So my kettle was boiling, so I had to just run out. On average, I drink like about at least 3 cups of tea, sometimes more for the whole day, each day. All right, where was I? Good. So here now, we never normally leave our answer as a negative power. So that's why I drag this x squared minus 1 to the negative a half into the denominator, and it now becomes a positive a half. And we're going to write our answer in the form that the question was given. So anything raised to the negative a half is just a square root of it. Pretty much the same thing I just said to Maria a while ago. We're reversing the order. See to yourself, a to the negative, sorry, a to the 1n, 1 over n is the same thing as a root of a. So it's as if we're reversing the order, and we get this as our answer here. All right. Let me give you.
Let me just run through what I understand, like a question like that. So first you convert the square root
Mm-hmm.
to x plus r, right, sir?
Sorry, yes, one.
When you differentiate using the term, the term, is what term again? The power term, the power rule.
The power, right.
You use you multiply the first term by the second term, and then you do the same thing. You run the first term by the you multiply the first term by the second term, and then you multiply the second term by the first term, right, sir?
Correct. The first times the differential of the second. I want him now first term and second term, and him something they know Marie. I know what you're talking about, but I want to say it's the first times the differential of the second plus the second times the differentiation of the first.
All right, and then you factor and you always use factor the smaller one out first. Part there. Then after you finish do all of that now, then you fix it up.
Same way, so.
And then after you fix up now, you get your answer. You never leave the answer with a negative point or a negative
power.
Negative power. So you convert it. That's what you say, sir.
Yes, honey. Very good. All right. So what I've done is to give you another product one. I'm going to give you 5 minutes. Matter of fact, what I'm going to do, I'm going to give, it's now 2 minutes to 9. I'm going to give you 10 minutes in total. I'm going to give you a 7 minutes break. A 7 minutes break. I'm going to drink my tea. And I would advise you, go boil a cup of tea, man, and eat 2 tough crackers with it in 7 minutes. But I'm going to give you 5 minutes to try this question, this number 4 question. I want you to try that for me. And we resume at 9:10. Please do not fall asleep.
Okay, sir.
Please. All right. So we're taking a screen break, and you have a question to do for me. All right. Sunko.
Thank you, sir.
All right, we're supposed to be doing question 4. Just a question. No?
Yes.
Thanks.
Yes, sir. What's the 4? But
Take a break first. Yeah, thanks.
All right. So welcome back. Welcome back. Are we finished?
Sir, I got an answer, right? But I
Mhm.
think I mixed up the powers at one point. Um, tell you the answer?
Tell me what it is that you got. Yes, son.
I have 7x open parentheses 9x square close parentheses over in the square root part 3x
Mhm.
square. But
3x
I'm
squared.
thinking there was something wrong with the 7x.
All right. All right. Look and see if I'm going to do the question and look and tell me if you agree with me so far. You agree with the first line?
Yes, sir.
Which first line?
Let y equal.
I was looking at the shaded part. Yes.
Yes, sir. That is the furthest I got.
Marie, don't let me hear you fall up. Don't let me hear you fall up, Marie. You know I love you. You know I love you too much to fall out with you.
Yes, sir, but there minute stuck. I got to there, so, and I was wondering where next.
All right. Look at my second line and tell me if you agree with me.
Yes, sir. Yes, me agree.
Nice. Yes,
But
sir.
me no know, me stuck too. So me no know where me gone
Yes,
wrong.
sir. I
Hold
got
on there.
that.
Hold on there. Hold on there.
I
Hold
got
on there.
that.
I know that is the
Sir. 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 Sir.
If you call the man
Okay.
2 times and 3 times and the man answer, I must think the man under there.
Hi, Miss Miserable. Why you taking me on? Okay. You get for your answer. Since you take me on. You get
What
this.
you got, Emilio?
I see if it on my laptop you have to punch it in. Or the square root button upon this thing. Alright, let's send the square root button. Alright, I get 7 square root 3x squared. I don't know. I know that right. Wild guess still.
All right. Where am I? 7x minus 3x plus third plus a 7. Where am I, guys? Where am I? The first. Help me out, guys. I lost my track. Okay, so we did up to this line already. So we agree up to this line. So I'm supposed to be working the other line now.
Yes,
Agree?
sir.
All
Yeah,
right.
yes, sir.
Okay, thank you.
Let me tell you what I get still. I don't know if I'm right, but I tell you what I get.
Shoot.
7 square root 3x squared.
For which one? For the final answer?
Final. Yeah, but I'm not sure if that's right. It's a ballpark.
Sonaki, how that differs from yours?
Sir, I have the 9x square.
No, based on what he says, you have the 9x squared from what you have?
Right.
All right. So somebody is right, somebody is off right.
All right, go on work out.
Where you get that? You know,
That's
say I
right.
square them in add it.
I'm not sure. I'm sure.
Me not get this right at all.
I never add the power. Me should have 21x square, but I only have 21x.
Mr. Shand,
Yes, honey bunches.
is there a shorter way to do this?
Don't ask me them question there, here, because you know that there is no shorter way. You know. Do you agree with this line?
Which line?
The one where the spotlight is at, the red something at.
Hold on, yes, sir. Hold on. All right, so you bring down the negative, because that's the smaller one. 7 into 21 can go, 7 can go into 21, so you bring down the 7x. Yeah, the left
Sir,
3x.
I have that line, right? But I didn't have the square at the 21.
Yeah, man, because remember 7x times a half times 6x. You remember that?
Yes, sir. I didn't add the x's.
Yeah. So let us go as we're doing it. So this is 7 times 6 is 42, and 42 times a half is 21. But this is x times x to give me x squared.
Yeah.
And then the 7x comes here, and that's right. Right. So that is correct. And what is common would be the 7. We take the lower of the two. So what is common is 7. It will be 7x as a matter of fact. And of course, the 3x squared to the minus a half. And then now 7 times 3 is 21. So we need a 3x here. This is the same thing as this here. And then the 7x times 1 gives me 7x. And this 3x to the negative a half times 3x to the positive 1 will give me 3x to the half. And then now I'm just going to have 3x plus 3x squared is...
Plus we plus the...
Yeah, plus.
Yeah, 6x squared.
So if me ever follow to say, Jesus vexed with us tonight. You can't add them because they're two different somethings.
Oh yeah, sorry.
Sure, you played me a little something in a bedroom. You might say you have to pass the course, you know. And every time when I want to fail the course, it means my stripes go down.
Might say,
When I'm supposed to pass my course. All right. So this one kind of look a little tricky-ish because right here I can actually take out a 3x inside of this to give me a x plus 1. I'm just going to do it and show you the correct stuff. So it's going to be 3, 7, so we're going to go back up to 21x squared. And then I have my x plus 1. And then, why I keep doing this? It's supposed to go to the positive half. Oh, this is not.
Mr. Sir?
Yes, please. I was just about to call on you, and I was just about to call on Tashana because I know she lost like day.
Oh, sorry.
When I say lost, she lost. She don't.
Remember when I don't know, I'm not sure.
Guess what now? You know, them I one song them sing, you know, light a candle, sing a Sankey, and find a way back home. That the song that for Tashana tonight.
Now hear her voice.
All right, so you want me to tell you where I lost from, sir? All right, you see that last part where you have dy over dx just before the red, that last line? How you get
this line?
Yeah, from where you have that line set out to get it to look like the one below in red.
Hold on, that's not the question. Hold on. Oh, see the question there.
Right, because you move it. You have I understand the 21x to the third power, that top line, but when you have to put it back again into the square root, like to bring it back to what it was, it's kind of confusing, sir.
Because the half there, so you basically I put it back to the square root version of the half.
Yeah.
Power half.
Because when you look at the negative half before in the last one, and I was trying to say, okay, so how that go? Then I try to confuse myself, so I was paying attention, sir.
Yeah. Bogle.
Right.
I'll come into you, Emilia, because you're going to be next. How far does this differ from your answer, Bogle?
Far, sir. Sir, I have 7x squared open 9x squared in the parentheses over square root 3x squared.
9x squared? How did you get 9x squared?
Sir, I'm all sorts of foolishness. Sir, I mix up from after the 21x squared. I mix up from there, right? Because
right. Look, watch me. Right here, so?
After there, sister, I got there.
So you have all of this right here, see?
Yes, except the square.
Except the square, the 21x.
Right, which I now understand, right?
You know, understand. All right, so let me take it from here then. Let me take it from here. And the rest of you, please pay attention. Let me take it from here. So Bogle around the place night and day. Have everything away from this two, the squared. Yes, please.
You can bigify it a little bit, please.
I can who?
Bigify it a little bit.
Oh, bigify it. Okay. All right. Let me bigify. No, she wanted to bigify.
Yeah, man, bigify it, man. I write word, man. I Jamaican word. That too bigified, though.
You know, we are just the best. There's none like us. You know, you can't bigify no more unless I'm gonna do it. Unless I'm going to do it this way. I'm going to do it this way.
Do it piece by piece and go on. Yeah, do it piece by piece.
I'm going to do it like this. All right.
You can bring it to 100 because it's at 220 right now.
All right. So yeah, we could stay right here. So this is a question.
Yes, sir.
So this is a question, and why the first, the second, So the different. So it's a product, and the product says that. Somebody said, sir, Marie.
Yes, I said. Whoa. No, okay. I got that section. I think most of get that part, sir.
Okay, good. All right, no problem. So it's the first, which is this, times the differential of the second here. This half comes right here, so in front of it. You can write 3x to the second power. You minus in 1 from that to the negative a half. And then you have to go inside to differentiate. So 2 times 3, 6x. So this is how I get the 6x here. Plus the second term, which is the 3x squared to the half, times the differential of the first. Shonake, you're right.
Yes.
Bogley, you're right. I put in an extra x, Shona. You're right. No, you're not right. No, you're not right. You're not right. Because it's supposed to be x squared, right? It's just that me have an extra x right here. So, but I threw my copy and paste it in a shortcut job load. All right, yeah. So it's supposed to be the x squared, right? So I'm correct right here, but I was incorrect right here. So when I differentiate the first, I'm going to get 7. So I'm going to have 7 in front of here. I was wondering why the answer came out to be this way. Let me tell you something. It's when you're doing the question and you know how the format of the answer. When I was doing this stuff, I said, but why did I get 3x plus 3x squared to the point where Emilia tell me 6x squared? And I was like, why do I get this? It's not supposed to be like that. But no, I understand because I had an extra x right here. So let's go.
Sir, why we remove the x, please? Because I'm
because we differentiate the first.
That's why I go back over now.
You differentiate the
go
first.
on again, sir. Start from the beginning.
All right, start from the beginning. The first, the second. First, the second. The first, this. Times the differentiation of the second. Differentiating the second is going to be a half. 3x squared to the minus a half.
All right.
Times the differential of the inside here. The differential of 3x squared is going to be equal to 6x.
Yeah, because 2 times 3, yes.
2 times 3,
and
6.
Minus the 1, left the x alone.
Right. So it's going to be 6x. Plus the second. So plus the second plus the 3x squared to the half. Times the differential of the first.
The differential of the first, which is 7
when you differentiate the first, you can get 7.
So hold on. If you get the 7 for the differential of the first at that time, why the beginning one have 7x?
Because when you write back the first.
Oh, you write it back. Yes.
Right.
Oh, because the first multiply by, yes, sorry, yes,
right,
yes.
Yeah,
you know, differentiate in the beginning. All right, yes.
Very
Totally understood.
Good. So now I am fixing up. So this 7 times 6 is 42 times a half is 21. X times x is x squared.
Sir, I'm gonna get it,
All right, hold on.
So why you couldn't multiply the 7 by the half?
Sir.
Sir, why we never drop off the x of the 3x square then?
The rule that we have, the differential, I think I have it on my notes here. We used to 7x, x is a dot after the 7x, and right in front of the half, and there's a dot in front of the 6x and a dot in front of the 7 at the end. So you know it's going to be 7x
multiply.
7 2 is 42, and when you times that by half, you're only going to get 21. Half of 42 is 21.
No, it's not that part I don't get. It's why we leave off the x, because when we do the differentiate.
All right, you see that x, the 7 on the end is differentiated. So when you know x is supposed to have a 1, and when you differentiate it, you know that the 1 going minus 1, so you're going to end up
minus the 1, so you're going to end up with the 7 alone, right?
The 7 alone you're going to get. If it was a constant there, if it was source of 7, you'd have no number to talk of. But the x is there, so we differentiate it. I don't know if I'm making any sense to you at all.
Yes,
so
but look now. Where you have 3x squared, right? You differentiate it and you said 3 to 6, and you put back the x.
Right.
Yeah, because the square, when you differentiate it, you got the square of minus 1.
2 minus the 1. All right.
Right.
So, no. You see 7x is x to the 1 power.
And when we get that part. I get it now. Thank you. Yeah.
Okay. All right.
Sir, look like him step away again. Give a minute.
Just get a part here too, you know, you guys explaining. Because I was wondering about the X same way, but I just understand it.
Okay, good, Marie.
As
Good.
you differentiate it, you take off the X. Instead, the X would have just come like 1 then.
No come like it. The X is a 1. It's always to the first power, which is 1.
Right. So because you differentiate it, instead of you come back with the 7X, you just come back with the X with the 7 one.
All right, you know how much time, so repeat the product rule. It says the first, which means as is how you see the first, so. Where you see 7x, that's the first, times the differentiation of the second, plus the second times the differentiation of the first. So this 7 is
show you.
All right, so Tashana, say it for me, please. It's the first?
The first times the difference.
No. Hold on there. You have to take time now, you know. You have to talk in a slow motion, right? So look here. This is the first.
The first times the differentiation of the second.
All right, hold up. And the differentiation of the second is going to be a half.
We bring the half to the in front.
Right, and 3x squared to the a half minus 1, which is going to be minus a half, times the differential of the inside now, which is 2 times 3 is 6x.
Put back that 6x.
And then continue now, Tashana, plus
the second times the
plus the second. So see the second here. So again, write it back. So every time I call the first Emilia, I write back what the first is. And every time I call the second, I write back the second, right? So I write back the second. Right, and then we differentiate in the first. The differential of 7x is 7.
Is 7.
Right, and then now 7 times 6. Okay, a half times 6 is 3, and 3 times 7 is 21. This x times this x gives me x squared, and I'm writing back my 3x squared minus a half, 3x squared minus a half.
Oh, so my question was, sir. It says 7x times 6x. Why it couldn't be 7x times a half? Because the 2x, you have to deal with the 2x them first.
Not necessarily. Same difference. 7x times a half is 7 over 2x.
Oh.
You see what does that mean now? People can say, Lord Jesus, a fraction. So that's why I did
confusion
it. Right. So that's why I did it the way I did it.
Sir,
so that's why, yes, please.
I am not trying to bother.
No. Sita, hold on. Marie.
Not bothering him.
Marie.
I encourage you to ask questions, Marie. I want to make sure you get it.
That's what make it the PA. So none of your questions is a bother. Hawks me. Yes, please.
This one is, sir, because you're not paying me any mind as it relates to it.
What she say?
I'm saying this question is a bother because you pay any mind to it, sir. All right, you see, I learned by
repetition.
Yeah, repetition, right, sir. For a better word. Sir, you see, like these, especially the last 3 recordings, I don't need any more.
So guess what happened now? So stick a pin. So I created a YouTube channel. As a matter of fact, I am actually putting, oh Lord. I actually have it here.
Sir, remember how you usually do it, you know?
No, hold on. Let me show you. Close that. New share. All right, so this is what, I don't know if you're seeing something here. Are you seeing this here?
Public, yes, sir.
All right, so for quite some time, I had created a YouTube channel. So I could put all my recordings in here.
Yes.
So my recordings for some other classes are in here. So I have it up because I'm actually picking up the recordings from this one, so that I can, sorry, I was reading a message, so that I can drop them inside here. But the challenge is these are some old time ones from December 2020. So what you have to do when I give you the stuff is to, as a matter of fact, I'm going to give you the address for the channel tonight. I mean, I'm going to put it in the group.
Address already. Is it this
Great. It's the same address, Marie. So what I'm doing, what I am in the process of doing now, honey bunches, you can send that address into the group for me. I am in the process now of dropping those stuff into it, into the channel itself. So I actually started, but I was having some challenge getting it done up. But I have started the process. So yes, so I'm showing you what it is that I'm doing, and what I have done is to leave some old ones there. What I may need to do is to rename these old classes. So at least, you still can look at some of the old classes because it's the same business calculus. So like this one, for argument's sake.
Look like you're a cook, sir.
No, man, normally on a Saturday morning when I have my class, I will give the students breakfast in the mornings.
Some fine breakfast, sir. Sir, I mean, I eat them something there with blueberry, pancake. You know what got their breakfast here?
Yeah, I had Jenny, visiting one or two other classes, so she would have seen some of those breakfasts. So what I am doing is I don't even know which course this one is.
No, sir, pre-calculus.
This one is pre-calculus, right? So what I'm doing is I want to rename these stuff as pre-calculus, business calculus. So you can, when you go into the YouTube channel, no matter where it is, you can just pick up all the business calculus and look at it. And this way is to keep students alive. So yes, I am in the process of doing it, Marie. I resurrected the stuff, and I am putting the stuff in the stuff. So you can see all the videos here. So I'm going to ask you to share the stuff. Tonight I'm dragging some more stuff into it, but what I need to do. All right. Oh, so that is I was wondering who was talking, but that is me talking in the background here. So what I'm trying to do, Marie, so that I don't confuse you guys. So it's like, oh, this one is pre-calculus. I need to go back into the YouTube and just name it as pre-calculus so that you can pre-calculus 2020, and then I will name this one as business calculus 2021, so you know which ones to pick up. And if you want, you can go back to a business calculus from whenever I would have taught the stuff. And this is my plan of action in my YouTube channel, so that I can have all the classes, all the recordings there. So at any point in time, when I can pick up something that I would have taught. Fair enough? So I remember you. I saw the stuff, and I'm working on it. Yeah, man. No problem. Yeah, man. So I don't want you to see that I'm not doing what I'm supposed to. Yes, Chris.
Rich.
It rich?
Rich. I mean, YouTube money you're gonna make.
No, man. This is only for Uno. No, I don't want the money. This is for my students. So, I don't want the recordings to just go to waste.
Sorry, you put in the link in the chat or somebody write
Marie's gonna put it for me. Marie's gonna put the link for me. Thanks, Marie. All right, let's just see if we can finish off this, because time is of the essence. You know what I'm gonna also do? I'm gonna see. It's because I didn't get a chance to do the what do you call it? Oh, the stationary point tonight. I'm gonna see today's Tuesday. Lord Jesus, tomorrow's when they have that meeting tomorrow. I'm gonna see if I can create a video and put in the channel itself too about the stationary point, something on the stationary point, one of the questions that I would have done on the stationary point, so that you can have a look at it before next class, because our next class is Thursday. Lord, I'm putting myself under pressure right there. Press pause on that, because tomorrow is going to be a tight day. We had an item writing session for the summer exam, and so I was in a session all day today, well, for up until about 2 o'clock. And I have to revisit those 2 papers, including your business calculus paper. I should be telling you that, but anyhow. So I have to go back to that, because those papers will have to be sent off to CCCG tomorrow. So I know I'm going to be tight for tomorrow for the stuff. But anyhow, let's go.
Make sure they're easier, sir.
All right, let's go. Yes, Anna.
Yes, state when is the mid-semester at the starting of the class?
No, I didn't.
Okay.
I have the mid-semester here now, but let me tell you what is happening. Matter of fact, all right, let me just finish off this, and then I'll give you some juicy information. All
okay,
right.
sir.
where am I now? Okay, so we're at the point here where we have the 21x squared times 3x squared to the negative a half plus 7 times 3x squared to the positive a half. Now, look here. I am taking out the lower of the two. So between 7 and 21, it's going to be 7. So I'm factoring out the 7. But only the 7 can factor out because this is x squared and I don't have any x squared right here. Talk truth.
Right, sir.
Good. So what is so in this case, watch me now. So in this case, I am going to have this because I don't have the x squared, so I have to leave the x squared. So what do I multiply by 7 to give me 21x squared? It has to be 3x squared.
Yes, sir.
Good. And then now, so I'm going to have 3x squared because all of this piece is this. And then 7 times what gives 7 is going to be 1. And then this is going to be 3x to the first power. 3x to the first power. So, yes, please.
Where you have the 7 in front of the 3x squared above the green writing, you bring down x here because it's 7 3 is 21 up there. But where you have the brackets again for the 3x, you just bring down the 3x and the half just disappear, right? That's it?
The half disappear because it's to the first power.
Okay.
You remember the half gone to the first power, because you remember what I multiply by.
The magical one, sir.
Very good. The magical one, yes. The magical one, yes. So it is all of that. Fair enough?
Yes, sir.
All right. So let's go. So now, so this magical one, let me just put it there. The magical one that is here would give me what I multiply by 3x squared to the negative a half to give me 3x squared to the positive a half would be 3x squared to the positive 1. When the bases are the same and I multiply, I add the powers. Negative a half plus 1 is going to be equal to positive a half. And because this is raised to the first power, I can remove the parentheses. So I'm going to have 3x squared plus 3x squared, which will give me 6x squared.
Where me get 9 from?
And then this 3x squared to the negative a half goes in the denominator here, so it becomes positive a half, and the 7 is that. So the 7 is this 7. This term is what is in the denominator now, but it changes to a positive, and this 3x squared plus 3x squared gives me the 6x. Fair enough?
Yes.
And
it's an next, we miss a step, but continue close. Me I see the closing.
Sir, I think I see it. When you have the two 3x's, they are the same. So you add the where you have up there, sir. Where did I can't call it parentheses? The brackets are you have 3x squared plus 3x squared. When the two what you call them again? Those two variables in front are the same, and the actual powers are the same. What is it that you're supposed to do? Keep the powers as is? I'm remembering vaguely. You don't add them because the base is
powers are the same, so the power remains the same, but you add the coefficients.
Which one is a coefficient again, please?
The power.
The head hurt me.
Power.
The power, okay. So
sorry, me say it wrong.
No man, say different. Coefficient. No, right. It's not the coefficient, but the power.
The power.
Right. So let me just go through this last part again. It says here, this 7 is this 7. This 3x squared to the negative a half is this 3x squared to the positive a half, because I take this now into the denominator. So taking the 3x squared to the negative a half to the denominator, I get 3x squared to the positive a half. And this 3x squared plus 3x squared is going to give me 6x, which is this here. And because 7 times 6x is 42, it's going to be 42x squared over all of this right here. So we can't cancel the x squared. No, they're two different something. This is the square root of 3x squares, and this is 42x squares.
Sorry, can go up to the first part, the question, the actual question itself, please, sir.
Sure.
At the top, 7, 3.
Sir, cannot be simplified some more.
Thank you for asking, Ricky.
Because I'm looking at it and I'm seeing.
Wait, can we simplify that a little bit more?
14.
No, no. Because remember, no, under the square root sign is where I have the 3x squares.
Oh.
Under the square root sign is where I have the 3x squares. Now the truth is, I could sneak in another step, because, and I'm not going to do it. I'm going to leave the answers there. But Ricky seems to ask, and that's why I said thanks for asking. You see the 3x squared, the square root of 3x squared in the denominator. I couldn't get it. I couldn't get that answer. Okay, so that is the same thing as the square root of 3 times the square root of x squares, and the square root of 3 is just the root of 3.
All right, so what I'm hearing is that magical 2 that would be in that little corner right there, you could actually differentiate a little bit more.
No, not differentiate. Not differentiate. Let me show you. Let me show you, but I don't want. I'm not. What am I doing here? Let me show you, but I'm not necessarily expecting you to do it. But let me just show you what is happening right here. This piece, that piece. What am I call this now? That piece, I could say copy, paste. So look at what is happening here. So the square root of 3x squares is the same thing as the square root of 3 times the square root of 3x squares. Rubbishness. The square root of 3x squared, the square root of x squared, right? The square root of 3 times the square root of x squared. You follow me? And then I could say to you, Toppy, I could say to you then from here, and this is just big stuff. The square root of x.
Thank God it not got so far.
Right. The square root of x. And I won't ask you to do this. I won't ask you to do that. The square root of x is just x. And then now that x, I won't even save this to the document. That x could cancel, this x could cancel with one of the x's up here to give me to give me 42x over the root of 3. It will give me 42x over the root of 3. And so that could be the simplest. But you see all of that now, you see all of what you see on the screen here, those 4 lines, that's big stuff, big school stuff. If this was calculus 1, I'd have said to the students, give me an answer down to that simplified form. But no, Ricky, you can't say, but sir, you can't go further, no, because 3 into 42 goes 14 times. No, that is a root of 3. That's
right,
a root of 3.
Is not a division yet.
Right, unless I'm going to write 42 as a third. The root of 3 is called a third. And I'm going to, matter of fact, leave that alone. This is big stuff.
Sir, take time with it, please.
Yeah, this is.
That's all, sir.
Yeah, this is bigger stuff. Bigger stuff. That yeah. So leave this as your answer, and you're good to go. You're good to go. All right. Now I'm gonna pause right here. I'm gonna pause here for tonight and just have a brief conversation with you. Though I will send this information into the WhatsApp group, especially for those of you who are not here, for those that are not here, because you guys are here.
Sir, I have some miserable dog next door, then started singing.
All right. No, I'm just saying to you that
sir,
you're not hearing? Anybody hearing me?
Hardly.
Yes, sir.
Yes, sir, hearing.
All right. All right, so what I'm saying to you is that for your mid-semester, limits is a must. You're going to be getting limits, piecewise function, average rate of change, and first principle differentiation. Limits, piecewise function, average rate of change, and first principles differentiation. All right. As I said before,
Repeat one more time, please.
Limits, piecewise functions, average rate of change, first principles differentiation. Now, as I said before, your mid-semester has been written for, and your exam too, for quite a while. From in the first week of the term, your papers were submitted. All right. We had an exercise today to do something with other colleges, read the papers. Now, I want to start preparing for your mid-semester. I'm going to drop it one day next week. I will tell you on Thursday which of the days. One of likely, yeah, I'll tell you which of the days, either Tuesday or Thursday of next week that I'll drop it. All right.
Sir, not drop it in on the 5 to 7 or 7 to 9.
Drop it where?
7 to 10.
Where I said the mid-semester you drop or the time, the day when you are going to drop is the mid-semester.
The weekend.
When you want me to drop it? Which day?
On a weekend.
Can't take it. The weekend still in us, sir. I don't mind.
You want it on a weekend?
Yeah, man. The more we get in on the weekdays, yeah, like how we're behind.
Sir.
So where's the first principle? What?
First principles, limits,
weekend goes, sir, and piecewise function.
Piecewise function, yeah.
Let me repeat it all first. Limits, piecewise function, average rate of change, first principles differentiation.
First principles differentiation, yeah.
Sir, what time would it be on the weekend?
No, man. All right, do me a favor. Uno, have the conversation in the WhatsApp group. I will watch it and hear what is happening because I'm cognizant that there are only 17 of you, 16 of you here. Are coming to your honey bunches. There are only 16 of you here, and there are others who may be affected. I know Yana does weekend classes.
So I have one from 8. I have a class from 8 to 11:30.
No, sir. The issue is I might not have light. Ergo internet over the weekend because of the people that were like trop. If the exam is sometime in the week, I can't even run go work, go try log in and do it there. But
no, but it's not this weekend and matter about in the
I know, but I'm saying, sir, on a weekend when they have curfew, it's not like we can left me out and go somebody else here go to the exam.
No, about
this
weekend.
God no, Tashana.
You leave work at night, you leave home at night, go work.
Are you listening to me? I said I was stranded. I had no internet here because thief in the area string up.
No, we heard that. We heard that.
No, but
so
what I'm saying,
when curfew start 3 o'clock Sunday, me panic.
If we're supposed to do it 7 to 9, right? The curfew starts at 8 o'clock. How do you go to work if you don't have any internet?
All right. So what I'm saying to you.
During the week,
okay, hold up. And I'm saying to you is, Tashana, I hear you and I understand, right? And this is why, to be honest with you, our secret, this is why I'm gonna like go outside of the regular class time because I know I'm gonna have these nuances to deal with. But guess what I'm saying? Tashana, see if you can sort out, because it's not this Saturday we're going to talk about, It's not this Saturday, unless you don't want it this Saturday.
No, sir.
No.
Okay, all right. So because I had said to you that I'm going to give it a mid-semester next week, it wouldn't be for this Saturday. It will be for the following Saturday.
All right, I'm praying that I have light then, sir.
Which is what I'm saying. So you have enough time to sort out. And let me just check the date again. So this Saturday is the 7th to be the 14th. Yeah, man, the 14th should be fine because, all right. So do me a favor. I am cognizant because Yana has a class up to 11 o'clock. The truth is, I have a class from 8 o'clock to 12 o'clock. My class was 2 students. All right. Matter of fact,
So you couldn't open it from like the 12 o'clock the week, they Saturday to 12 o'clock, 12 o'clock in the midday, Saturday to 12 midnight Sunday.
Oh no.
No man, and you do it within that time frame. You do it within that time frame, within the normal time limit on the thing.
No.
Mr. Shan, the film exam them
From
different
Saturday,
like
me never
one in
have
the
no
class.
lights, and it's not JPS, and
No,
it's
man,
Sunday
it has to
evening,
be
the time to get back electricity.
It has to be all right. So we'll have a conversation in the group. No, so that is the for the mid semester. As I said before, Marie is going to assist me by sending out that information in the WhatsApp group for me.
She do it already, man.
Okay, fabulous. Thank you, Marie. And then now I'm going to start putting before I put in the stuff in there, I need to rename the ones that are there before so you don't get confused, right? Or maybe it can differentiate it by dates. But nonetheless, yes, honey.
Sorry, sir.
No, sorry, no, hold on. Somebody coming in before you, Tashana. Go ahead, please.
All right, sir. Based on that is only 1 week I have to go through. You can drop them in and then when you finish, you fix them up, sir.
All right, no problem. I can do that then. I can do that, Marie.
Yes,
I can do that.
Sorry, remember I never sent last week paper yet.
Don't say that. Don't say I'm Ophelia Henry Johnson.
It was sent on the 29th.
Before the class was done.
Right.
I sent it before the class was done.
Oh,
so please
sorry, I'm not check no message yet. I'm not check no phone.
From 5 years ago, you know, miss.
Before we log out from class or send another chat.
Before I log into it, man, I sent it. Trust me. Check your WhatsApp. Before I sent. Before
You mean from last week, sir?
Yes. Before class done.
All right, now can I ask my question? I heard that Marie sent something in the chat. I don't see anything in the chat.
That's all right. It's in the WhatsApp group.
Okay.
It's the YouTube link that she sent.
Right.
It's to the page.
Okay, I see it. Thanks.
Okay.
Let me make it people.
Yes or no? I'm gonna be there at 10 o'clock. I'm tired.
Be glad you said, sir. Come here, me there, you pat me foot and say, God, man.
Come here, book too, you know, me tired.
Have a wonderful rest of the night. We'll continue this conversation in the WhatsApp group. So when I wake up, I can continue. Bless in the heart here.
Sir, just send it. Sir,
yeah.
Please remember to
what's up with the 4 topics? Yeah, because I'm gonna do it right now, Babylon good there. You know.
All right then, cool. Bless up.
Babylon can't lock you up, man. You see, you're top boss.
Yeah, it's
no official papers. Okay, so not a word.
All right, later, guys.